Today's topic is composition of universe. As we know that in the universe we can see the matter, and there are 5 states of matter: solid, liquid, gas, plasma and Bose-Einstein condensate. Plasma is super hot and Bose-Einstein condensate is super cold, and this matter is made up of the atoms, and these atoms are made up of the neutron, proton in the nucleus and electron in the orbits. These neutron and protons are made up of the quarks. Anything that is made up of the 3 quarks is known as Byronic matter. So whatever matter you see in the universe, that is actually the Byronic matter, because each and every atom is made up of the neutron and proton, or proton, and these protons and neutrons are made up of the quarks. Basically the 3 quarks. Proton is made up of the 2 up quark and 1 down quark. Neutron is made up of the 2 down quark and 1 up quark. And whatever these proton and neutrons, they are made up of the 3 quarks, and whatever is made up of the 3 quarks is known as byrons. So the matter in the universe, in this vast universe, the composition of matter is only 5%. Whatever the star you can see, whatever galaxies you can see, they constitute only 5% of the universe. Then what is rest of other things? पहले तो इसी 5% का डिस्ट्रीब्यूशन क्या है ये देख लेते हैं. Approximately 0.03% we have heavier elements, and what are these heavier elements by which me and you are made up of, by which the planets, asteroids, these are made up of? All the metal that you can see, these are made up of the heavier elements like iron, like uranium, like thorium, like gold. These are the heavier elements, and this is only 0.3% of the universe, not of the universe, of this 5%. And the other thing, it is 0.3%. these are neutrinos, and neutrino को हम घोस्ट पार्टिकल भी बोलते हैं. they are ghost particles. Why they are ghost particles? Because they are so small, then they can cross the complete earth. Complete diameter of earth can be crossed by the neutrinos without interacting even a single atom. और अगर interaction भी होगा तो बहुत कम होगा. So they can cross complete diameter of the earth, and even each and every second these neutrinos are crossing you. Millions and billions of neutrinos are crossing you. Are you able to detect them? Are you able to know that, wow, this neutrino crossed me? No, you are not able to detect the neutrinos. Even you don't feel that millions or billions of neutrinos are crossing you each and every second. जैसे बॉलीवुड की मूवीज में होता है ना कि आत्मा आई, बॉडी को क्रॉस कर गई, और उसी आत्मा को तो तुम घोस्ट बोलते हो. ठीक है, दैट इज वाई दे कॉल दिस न्यूट्रिनोज एज द घोस्टली particles. That is why they call these neutrinos the ghostly particles, and they can be free. They can be independent. They do not participate in the making of the atom. They do not participate in the making of the atom. And the next thing is your hydrogen and helium. Hydrogen and helium is approximately 4%. जो हमने 5% मैटर की बात की, 5% मैटर की बात की, उसमें से approximately there is 4% hydrogen and helium, and this hydrogen and helium is found in the nebulas, and this nebula is star making. This nebula is star making factory. बाकी का approximately 0.5% this is found in the stars. स्टार्स भी मोस्टली बने हैं किसके? हाइड्रोजन और हीलियम के. दिस हाइड्रोजन एंड हीलियम इज फ्री. अभी इसने स्टार नहीं बनाया, बट इन द फ्यूचर इट विल मेक द स्टार्स. एंड दिस हाइड्रोजन एंड हीलियम विच आर स्टार्स हैव, it is only 0.5%. So this was the story of matter. Next thing is your dark matter. It is approximately 25 to 28% of the universe. Do not confuse the dark matter with the black matter. It is not the black matter. ठीक है. What is this dark matter? Why this thing is called the dark matter? Because this dark matter does not interact with Byronic matter. This dark matter does not interact with Byronic matter, and even it does not interact with electromagnetic waves. As I told you, Byronic matter, whatever matter is made up of the proton and neutron, that matter is called the Byronic matter. So dark matter is not interacting with the Byronic matter, and even it is not interacting with the electromagnetic waves. As I have told you in the previous lecture, that electromagnetic waves are gamma rays, X-ray, UV ray, visible ray, then your infrared, then your microwave, then your radio wave. These are the electromagnetic waves. Dark matter is not even interacting with the electromagnetic waves. That is why it is very difficult to detect the dark matter, and it has so huge composition in the universe. Then what is the role of dark matter? How do we know that there is dark matter in the universe? So the role of dark matter is to holding the universe together. What dark matter does? Dark matter hold the universe together. This is the role of dark matter. Then the biggest composition, we have dark energy. This has the biggest composition in the universe, approximately 68 to 70%. We have dark energy in the universe. Actually, I am writing like this because in the different sources there is different data about the dark matter and dark energy. Some says ki 25% dark matter and 70% dark energy. Some says 27% dark matter and 68% dark energy. That is why I am writing like this. This dark energy also does not interact with, it will also not interact with electromagnetic waves like the dark matter. It will also not interact with Byronic matter. Then how does we know that there is dark energy in the universe? And with this huge composition, how can we know that there is dark energy in the universe? So we will see the role of dark energy. Then only we can know that there is some dark energy in the universe. The role of dark energy is, it is expanding the universe and as we know that universe is still expanding, it is because of the dark energy. So this was the composition of the universe, and there are some experiments going on. There are some missions by which we can detect the dark energy. The European Space Agency send a probe to the space to detect the dark energy, and it is your Euclid mission, and they send the Euclid mission in the heliocentric orbit so that they can detect the dark energy in the space, and they can detect the dark matter also in the space. Even in the Large Hadron Collider that is situated in the Switzerland, over there we are also doing some indirect experiments so that we can detect the dark matter and dark energy. In the Ice Cube Neutrino Observatory, we are detecting the neutrinos. This Ice Cube Neutrino Observatory is in the south pole of the Earth. This will also detect the indirectly dark matter and dark energy. There are some direct experiments which are going on to detect the dark matter and dark energy. These are Lux Zoplin and liquid xenon experiment. These are so mysterious forces that till the date we could not detect the dark matter and dark energy. We have whatever we know about the dark matter and dark energy is whatever we know about the dark matter and dark energy by the indirect sources. So this was the complete composition of the universe. Let's read this. Astronomers now realize that universe main ingredient is dark energy, and how much dark energy is there? Approximately 68 to 70%. The next largest constituent, that is dark matter, it is approximately 25 to 27%. The rest of the universe is consist of the ordinary matter. Most of it in the locks up in the stars and clouds of gases. Stars के बारे में पता है, clouds of gases, we know that this is nebula, and a tiny fraction of this is composed of heavier elements, the stuff by which humans and planets are made up of. This heavier elements make the Earth, asteroids, these are the planets. ठीक है, and what is this heavier elements? As I have told you, gold, iron, nickel, uranium, thorium, and this is very less in the universe. It is only 0.03% of the universe. Your ghostly neutrinos are 0.3%, and in the stars, as I have told you, that there is only 0.5% of the matter. Free hydrogen and helium is approximately 4%. Then your dark matter is 25 to 30%, and your dark energy is 65 to 70% के आसपास your dark energy. So this was the complete composition of the universe. Thank you very much for staying with us. Please stay healthy and stay fit.